Hey guys, welcome back. Today we're going to do more of the same, pretty much the exact same thing we did yesterday. I'm going to keep it a nice simple example and talk about basically the difference in setting them all up, okay? So first you want to make sure you have a really good graph. So you might want to hit pause and try to graph the shaded region first. You may want to even do your graph eventually in pen so that every time you have a new problem, part A, B, C, or D, you can just erase the radius each time and not have to regraph everything. So we have a parabola y equals x squared, okay? We have the line x equals 2, which goes through the x-axis at 2, and y equals 0, which is the x-axis. So this is my shaded region. And you might want to just go over that in pen, okay? Because you're going to use that shaded region for all 4 problems, okay? So the first thing I want to discuss is how do you know when it's a disk method versus a washer method, okay? And it all has to do with, is this shaded region, is the shaded region flush up against the line, or is there space between the shaded region and the axis you're rotating it around? So my first question would be, what could I rotate this around so that this would be a problem that is the disk method with just one R, one radius? Well, the answer to that would be I could rotate it around the x-axis, and that would be a 1R problem. Or I could rotate it around this line, x equals 2. That would be a 1R problem. Any other line that I try to rotate it around, it's going to have space between the shaded region and the axis of rotation. So every other problem will be a washer method with 2 R's, okay? So let's do the first one, rotating it around the x-axis. If you think you know what you're doing, hit pause and write down the setup for that problem. If not, keep listening. Okay, if we rotate it around the x-axis, okay, then it's just a 1R problem, the disk method, pi times big R squared, and that's it. When we go around the x-axis, we have x bounds. We're going to collect up our disks from 0 to 2. And R is the distance from the curve to the axis of rotation. So R goes from the curve down, and that curve is x squared. So it's x squared minus 0, but clearly you don't have to write the minus 0. Okay? That would be your setup for that one. Nobody marks off if you don't put the dx at the end. And this would be an easy one to evaluate by hand. So I'll let you hit pause and find the answer to that one by hand. Okay, simplify your integral. Then actually integrate power rule. This is x to the 5th over 5. Okay, plug in your 2 and your 0 and subtract. Plugging in 2 to the 5th, you'd get 32 fifths. Plugging in 0, you get 0, and don't forget the pi at the end. Okay, that was part A, rotating it around the x-axis. Okay, part B, we're going to rotate it around y equals 5, which is a line that is in the same direction as the x-axis, so it kind of is treated the same. Okay, so I'd like you to redraw the picture, graph the line y equals 5, okay, and see if you can do the setup on your own. I'll be right back. Okay, the line y equals 5. That's going to be somewhere like here. It could even go right through here, right where that shaded region stops, but it can't go through the middle of the shaded region, okay? So what I need to do kind of is figure out what is the height of that point right there. Well, x is 2 there, and if I plug in a 2 for x, you get that y is 4. So the coordinates right here are 2, 4, okay? So y equals 5 is 1 unit above that. So we have a line that's above the shaded region. Okay, now we're rotating it around that line. So first ask yourself, is there 1R or 2? Is this the disk method or the washer method? And to answer that question, is there any white space between the shaded region and the axis of rotation? And hopefully you say yes. So this is the washer method, 2 R's. So volume equals pi, and always write it like this, big R squared minus little r squared. It avoids a lot of mistakes, okay? Because this line is in the same direction as the x-axis, we're still going to have x bounds, 0 to 2. Okay, now big R and little r. Big R goes from the outside curve to the axis of rotation. Big R always goes through the shaded region. So big R goes from the outside of the shaded region, but then through the shaded region to the axis of rotation. Little r touches the shaded region and goes to the axis of rotation. Big R is literally bigger, okay? Now, big R is this, right? But when you subtract, you have to subtract from top to bottom. So subtract the two curves. This one is the curve y equals 5, and this is the curve y equals 0. So big R is just 5 minus 0. And obviously you don't have to write the 0. Little r is going to be the curve that's 5 to the parabola, x squared. So it's 5 minus x squared. You got to subtract from top to bottom. Okay? Now, on the AP exam, they often say just set it up, do not solve. So this would be fine. You could leave it like that. If you had to put it in your calculator, obviously I'd probably handle this, but leave this as it is and put it in my calculator the way it is. Okay? I'm just going to focus on the setup so this video isn't too long. Okay, so remember, when you do your radii, it's always subtract from top to bottom, and that's so that you get a positive length. Okay? All right, now let's try the y-axis. Hit pause, redraw your shaded region. I'll be right back. Okay, now we're going to rotate around the y-axis. Now when you rotate this way around the y-axis, now your circular discs are going like this. So when you integrate from the bottom up. You're collecting your circular discs going up. So that means you're going to have y bounds. So think y-axis means y bounds, okay? So right away, hopefully you can see, you're going to want to remember that these are y bounds, and they're going to go from 0 to whatever this point over here was, which was 4. So y bounds. As soon as I have y bounds, I also try to do this. Hopefully that'll remind me that all of this has to be in terms of y. Y bounds, y values. Okay? So next question is there 1r or 2? Well, is there any space between my shaded region and my axis of rotation? Yes. So that's going to be a 2r problem. So it's big R squared minus little r squared. Okay? Now I have to rewrite my equation in terms of y. So we can't have it y equals x squared. We got to get x by itself. So square root both sides, and you get that x is equal to the square root of y. Okay? It's actually plus or minus the square root of y, but we have the positive side. If it was over here, it would be the negative side. Okay? So my equation there, when we see that parabola, when we use that parabola, we're going to use this equation, not this one anymore. Okay, I had to regraph that and clean it up. Okay, so what do we have so far? We have y bounds. So remember, y bounds means you're going to have to find the y coordinate. This was an x of 2, but a y of 4. Okay, now we're going to find our radii. Remember, big radius, big R goes from outside through the shaded region to the axis of rotation. Little r touches the shaded region and goes to the axis of rotation. Okay, so big R would be 2 minus 0. Little r is the parabola minus 0. And the parabola is the square root of y. Okay, now this would be an easy one to solve by hand. So you may want to do that real quick because it would not be hard. And if you were going to put it in your calculator, you just treat y like a regular old x and put it in your calculator the same way. Okay? So go ahead and do this one by hand. Okay, the square root of y squared is just y. So that's what that simplifies to. Now when I integrate, I would get 4y minus y squared over 2, evaluated from 0 to 4. Now plug in your 4 and your 0 and subtract. Okay, when you plug in the 4, you get 16 minus 8. Plug in the 0, you get 0. So this should be a final answer of 8 pi. Okay, last one. We're going to now rotate around the line x equals 2. So regraph. Here we go. Okay, The line x equals 2 goes through the x-axis at 2, so that's the same as the line that was given as a boundary, okay? Now, it's a vertical line like the y-axis, so it's going to be treated like the y-axis, and you're going to need y bounds. So right away, I'm going to try to remember y values. So again, we plugged in a 2 and got 4, so the y bounds are going to go from 0 to 4. I'm going to try to remember I need everything in terms of y. So I'll have to rewrite this as square root of y again. Okay, next, if I'm rotating it around this line, does my shaded region, is there any space between my shaded region and that line? No. So this is a 1r squared. This is a disk method. So there's only one r, and r is going to be the distance from the curve to the axis of rotation. Okay, so that's my r. But remember, you want to subtract in such a way that you get a positive result. So for this one, you're going to subtract 2 minus the parabola. 2 minus square root of y. Okay? So if you're not sure why you subtract in that order, again, remember, if I had the line x equals 1 and x equals 4, okay, 1 and 4, the distance between them is 3. And the reason is we subtract from right to left, 4 minus 1, okay? All right, so big R, again, there was only one radius because the shaded region is completely touching the axis of rotation, so it's a disk method, not a washer method. And big R, you just subtract. It's curved axis of rotation, but you gotta make sure you actually subtract from right to left. So it was 2 minus the parabola, okay? All right, so that's it for today. It's, again, nothing new. I just want you to practice the setups, do a couple of them by hand, do a couple of them with your calculator, but do all of the setups without a calculator. So make sure you set up the problem completely on your own, okay? Good luck, guys. Hope you're doing well. Bye.